According to the National Electrical Code, specifically Section 250.120a, a separate bonding wire is required from conduits entering steel cable trays under specific conditions. Understanding these requirements is crucial for ensuring electrical safety and code compliance. Let's break down when a separate bonding wire is necessary and when it is not. Firstly, a separate bonding wire is required when the conduit is not a metal-clad cable with an approved bonding strip as described in NEC Section 396.40. This means if the conduit is a standard metallic conduit without a designated bonding strip, you will need to install a separate bonding wire. Secondly, a separate bonding wire is also required when the conduit is made of non-metallic material such as PVC and the cable tray is not grounded. In this scenario, the non-metallic conduit does not provide a conductive path for grounding, so a separate bonding wire ensures that the cable tray is properly grounded. Now let's consider the situations where a separate bonding wire is not required. Firstly, if the conduit is a metal-clad cable and it has an approved bonding strip, a separate bonding wire is not needed. The bonding strip provides the necessary electrical connection. Secondly, a separate bonding wire is also not required when the non-metallic conduit enters a grounded cable tray. In this case, the grounded cable tray provides the necessary ground path, eliminating the need for an additional bonding wire. Understanding the method of bonding is also essential. The bonding wire must be at least the same size as the grounding conductor in the conduit. This ensures that the bonding wire can effectively carry fault current. The bonding wire must be connected to the conduit at both ends and to the cable tray. This creates a continuous electrical path. The bonding wire should be installed throughout the entire length of the conduit inside the cable tray. This provides a reliable and consistent ground connection. It is important to note an exception outlined in NEC Section 250.120b. This exception allows for the omission of the bonding wire requirement for conduits with a length of 18 inches or less, provided that both of the following conditions are met. Firstly, the conduit must be fastened to the cable tray with metal fasteners. These metal fasteners provide a degree of electrical conductivity between the conduit and the cable tray. Secondly, the conduit and cable tray must be bonded together at one end. This ensures that there is at least one point of electrical connection between the conduit and the cable tray. This exception is intended to address situations where short conduit runs provide minimal risk of electrical faults. It is crucial to consult the specific requirements of the National Electrical Code and any local amendments to ensure compliance with all applicable regulations. Incorrect bonding can lead to dangerous electrical conditions and potential safety hazards. Proper bonding and grounding are essential components of a safe and reliable electrical system. It is also important to understand the purpose of bonding and grounding in electrical systems. Grounding provides a low impedance path for fault current to return to the source, which allows overcurrent protection devices such as circuit breakers and fuses to quickly interrupt the circuit. This minimizes the risk of electrical shock and fire. Bonding, on the other hand, connects non-current carrying metal parts together to create an electrically conductive path. This ensures that all metal parts are at the same potential, reducing the risk of voltage differences that could cause electrical shock. The combination of bonding and grounding provides a comprehensive safety system that protects people and property from electrical hazards. When working with electrical systems, it is essential to follow all safety precautions and to use appropriate personal protective equipment such as insulated gloves and safety glasses. Always de-energize circuits before working on them, and verify that the circuit is de-energized using a voltage tester. If you are not qualified to work on electrical systems, consult a licensed electrician. In addition to the NEC requirements, it is also important to consider any local regulations or codes that may apply. Local jurisdictions may have additional requirements or modifications to the NEC that must be followed. It is always a good idea to check with a local electrical inspector or building department to ensure compliance with all applicable codes and regulations. Furthermore, it is important to maintain accurate records of all electrical work performed, including the location of bonding and grounding connections. This documentation can be helpful for future maintenance and troubleshooting. Regular inspections of electrical systems can help to identify potential problems before they become serious hazards. These inspections should include a visual examination of bonding and grounding connections to ensure that they are intact and properly installed. Any damaged or corroded connection should be repaired or replaced immediately. It is also important to ensure that the grounding electrode system is properly maintained. This system typically consists of one or more grounding electrodes, such as ground rods or ground plates, that are connected to the grounding conductor. The grounding electrodes should be inspected periodically to ensure that they are in good condition and that the connections are tight and corrosion-free. The resistance of the grounding electrode system should also be tested to ensure that it is within acceptable limits. A high resistance reading indicates a problem with the grounding electrode system that needs to be addressed. Proper bonding and grounding are essential for the safe and reliable operation of electrical systems. By following the requirements of the NEC and any local codes, and by performing regular inspections and maintenance, you can help to ensure that your electrical system is safe and code compliant. In summary, remember that a separate bonding wire is typically required when using non-metallic conduit to enter an ungrounded metallic cable tray. Also, a separate bonding wire is generally required when you are using metallic conduit without a built-in bonding means, such as metal-clad cable with a bonding strip. No additional bonding is needed when using metallic conduit with a dedicated bonding means or when using non-metallic conduit entering a grounded metallic cable tray. There is also an exception to the rule when using shorter lengths of conduit. The bonding wire should be appropriately sized, typically the same size as the grounding conductor within the conduit. This will help maintain electrical safety within the cable tray. Always ensure that the electrical continuity is maintained and that the resistance is low between the conduit, the bonding wire if required, and the metal cable tray. Poor electrical bonding could cause dangerous conditions. Always refer to NEC 250.120 and NEC 396.40 and any local codes that are applicable to you for specific scenarios. These codes are developed by the National Fire Protection Association (NFPA) and are updated every 3 years, so it is important to stay current with the latest edition. The NEC provides detailed requirements for bonding and grounding to ensure electrical safety. It is also crucial to select appropriate materials for bonding and grounding connections. Use connectors and clamps that are specifically designed for grounding and bonding applications. These connectors should be made of corrosion-resistant materials and should be properly sized for the conductors being used. Avoid using dissimilar metals in bonding and grounding connections, as this can lead to corrosion and reduce conductivity. For example, avoid using copper connectors with aluminum conductors, or vice versa. If it is necessary to use dissimilar metals, use connectors that are specifically designed for use with dissimilar metals and apply a corrosion inhibitor to the connection. When installing bonding and grounding conductors, be sure to route them in a neat and orderly manner. Avoid creating sharp bends or kinks in the conductors, as this can reduce their conductivity. Secure the conductors to prevent them from becoming damaged or dislodged. Label all bonding and grounding connections clearly and accurately. This will help to ensure that the connections can be easily identified and inspected in the future. Use permanent labels that are resistant to fading and weathering. Keep accurate records of all bonding and grounding work, including the location of connections, the size and type of conductors used, and the date of installation. This documentation will be valuable for future maintenance and troubleshooting. Regular inspections of bonding and grounding systems are essential to ensure their continued effectiveness. These inspections should be performed by qualified personnel who are familiar with the requirements of the NEC and any local codes. During the inspection, look for signs of corrosion, damage, or loose connections. Test the resistance of the grounding electrode system to ensure that it is within acceptable limits. Any problems that are identified during the inspection should be corrected promptly. Proper bonding and grounding are critical for electrical safety. By following the requirements of the NEC and any local codes, and by performing regular inspections and maintenance, you can help to ensure that your electrical system is safe and reliable. Always prioritize safety when working with electrical systems. Wear appropriate personal protective equipment to energize circuits before working on them, and verify that the circuit is de-energized using a voltage tester. If you are not qualified to work on electrical systems, consult a licensed electrician. Remember, electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electrical hazards. In addition to following the NEC and local codes, it is also important to stay up to date on the latest industry best practices for bonding and grounding. Attend training courses and seminars to learn about new technologies and techniques. Read industry publications to stay informed about current trends and issues. By continuously learning and improving your skills, you can help to ensure that you are providing the highest level of electrical safety. Proper bonding and grounding are not just a matter of code compliance, they are also a matter of ethical responsibility. As electrical professionals, we have a duty to protect the public from electrical hazards. By following best practices for bonding and grounding, we can help to ensure that our electrical systems are safe and reliable for everyone. Always remember that safety is paramount. Electricity can be dangerous and deadly, so it is essential to take all necessary precautions to protect yourself and others from electrical hazards. By following the NEC, local codes, and industry best practices, you can help to ensure that your electrical systems are safe and reliable. And never hesitate to consult a licensed electrician if you have any questions or concerns. Electrical safety is everyone's responsibility, and by working together, we can create a safer environment for all.